Hello. In this video, we will learn how we can make engineering drawings in Creo. Previously, we've been focusing on making 3D models, which is absolutely essential to convey three-dimensional details of our design. But you don't have access to a 3D viewer, let alone CAD modeling software like Creo all the time, and you need to be able to convey the important design details on in a 2D form, namely on an engineering drawing which can be printed. You might need engineering drawings for requesting manufacturing of a part. You might need to convey it. You might need to give that engineering drawing to a machine shop, or for internal communication there is a very important role for engineering drawings. Thanks to 3D modeling software, CAD software, we don't have to make those engineering drawings on a 2D plane directly. What we can do is that we can make 3D models, and then Creo uses projection theory. We've discussed what projection theory is to make 2D projections, either multi-view projections where we're looking at things perpendicularly on the three principal planes, or pictorial projections where we are looking at things at an angle and can look at the three-dimensional view of our 3D object. So let's see how we can make a 2D drawing, an engineering drawing of a model that we've created in the past. Like any project, first thing to do is set your working directory. I've done that over here. I'll use the example of a spur gear that we've been working on previously, or let's actually use this bevel gear. I'll open this bevel gear. This is a part file, and uh, once you've opened it, now when you start an engineering drawing project, an engineering drawing of this file that you have open will start to be generated. So after I have opened the 3D model that I want to work on, it doesn't have to be a part file. It could have been an assembly file as well. Next, I'll open a drawing project. So go to File, New. Instead of starting a new part or an assembly project, start a new drawing project. Give it a name. I'll call it bevel gear drawing. Instead of using a default template, set the size of your drawing yourself. I prefer A4 size paper drawings, because when I print those drawings, they are printed at the same scale, and I can actually get a sense of the physical size of the actual object, not only by looking at the dimensions, but by looking at the physical printout of the 2D drawing as well. So I'll select an A4 size paper over here, and I want to work with a landscape orientation. If you wanted a portrait orientation, or you wanted to set the size of your canvas yourself, use a non-standard size, you can do that as well. So now I have opened a new drawing project. It looks very similar to a part design or an assembly design project. It's the same interface, but it's a new window. The part file is open in the back. The first thing that I want to do is I want to add a pictorial view. I'm using third angle projection. So I'll add a pictorial view in this corner, and then I'll have the top view over here, front view over here, and the right view over here. So to add a pictorial view, or any view for that matter, you will select this option, which says general view, no combined state, and make this the default for your engineering design working, and then click generally on your drawing canvas. Your drawing canvas, your page is marked by this blue rectangle where you want to place that view. we can adjust the details of that view later. I want that pictorial view to be here. I'll click over here, and that view has been placed. I don't really like this orientation. So what I want to do is that I want to uh, select a different orientation, and you can do that by selecting a view of your choice. Over here, there are only two orientations available, which are the default and the standard orientation, which are the same. So what I'll do is that I'll pause over here for now. I have placed a pictorial view, but I'll go back to my part file and I'll save a new view which I want. And I want this particular view because I want the front view to be the view where I'm looking at the teeth of the gear, because I think that makes more sense in terms of understanding the part. And as we've discussed, the front view has to be one which is intuitive, which conveys the important design features of our artifact that we want the viewer to see right away. So I'll go to view, and I'll go to view manager, and I'll define a new orientation. I'll call it front 3D, click enter, close, and then in my drawing, I'll edit this view, this general view that I've created by going to its properties, and I'll select this orientation. I also want things to be slightly larger. So I can either go to scale over here and increase the scale. Right now the scale is 1, which actually might be beneficial. If you print this out, your parts would be printed to scale. But I think right now I want something which covers the page more evenly. So but instead of changing the scale just for this view, which I can do over here, I'll change the scale for the entire drawing so that all the views that I generate are scaled at that scaling value. So I'll double click over here and I'll change the scaling value to 2. So this part is twice as big as the actual part as per the dimensions that have been provided. I'm generally happy with this. I do want to get rid of the datums here, and I want the view display to be shading with edges, and that is what it is now. And that's a general advice that I would give, that for your pictorial views, use shading with edges, and for the multi views, the top, front and right views, use either a wireframe with or without hidden lines. I would avoid hidden lines to the extent possible because that makes things very crowded. I want to move this view slightly. When I try dragging it, it actually does allow me to drag it. Sometimes you might not be able to drag it. Now if I'm trying to drag it, it's not letting me do that, and that's because this button, lock view movement, is pressed. So if you want to move your views around, unlock the movement and then move them where you want to move them. I'll create a new general view. I'll place it over here, and this would be the top view of my multi-view, uh, my 3 multi-views. I want the top view to be the view which is looking at this from the top, and the projection cast on the plane above it. So I'll play around with the orientations, because this is a part that was imported from a step file that we downloaded from McMastercard. It doesn't have the default views. Ordinarily, you would have default views. So what I'll do now is to go in here and make a view that I want to be used as the top view. I'll go to View Manager, but before I do that, let me set up the view. I want this to be the top view. So view manager, new orientation, top, enter, close. So now when I start a new general view, I'll select this, and I want this to be displayed as a wireframe without hidden lines. I'm generally happy with this. I will move this down slightly. Yeah. For this view, one thing that I forgot to mention is that generally we want our pictorial views to be isometric, where the three principal axes are represented on a 2D plane with 120 degrees apart, which gives a sense of dimensions as well. So instead of using trimetric, we'll use isometric. And now what we want to do is that we want to create the front view. So once you have a general view, you can use that to create projections. So select this view and then select projection view, and then depending on where you want to place a projection of this view that you have selected as your base, you move the rectangle that pops up. I want to place it below this. Creo knows how projection theory works, so it automatically generates a front view, what I want to be a front view for me. I'll again go change the view display to no hidden, and the next thing that I'll do is I'll generate another projection to the right of this view, which would be my right view. Change the view display, and I'll get rid of the datum planes which are visible. I also want to get rid of this sketch that seems to be here. I don't know what that is. There's a sketch that was made for some reason. I'll hide that from here, and that should remove it from here as well. So now hopefully you can start seeing how an engineering drawing with three multi-views and one pictorial view following the third angle projection model can be developed. A few things are missing. We don't have any sense of how big things are, so we need to add dimensions, and then if you want to, you can add additional annotations as well. So let's see how we can add dimensions. So within your drawing, go to the annotate tab, and from here you can add dimensions. May follow the general best practices for dimensioning and tolerancing. Don't have repeat dimensions. Use the most appropriate view to illustrate the important dimensions. Avoid dimensioning on hidden lines. Do not have your dimension lines intersect. So those general rules of thumb and best practices for dimensioning. The first thing that I'll want to dimension is the size of this hub. So I selected the left line, the right line while holding down control, and I'll place the dimension over here. I could have done it differently as well using this view by defining the radius of this. Actually, I don't see this hub. If I had hidden lines, I could have defined the radius or the diameter of that, but I think this is more clear. I want to define the height of this hub. I can use this view. I could have used this view as well, but what I won't do is define it in both places. I'll define this hole through this burger. By default, it's represented as a radius. As you can see by this R which is popping up, if you hold down the right mouse button, you can change this to a diameter as well. I normally prefer diameters, but be consistent. So I'll place this over here by pressing the center mouse button. And in this way, you can add all the important dimensions that you think are needed to convey the size of your part. You can change the font details of your dimension. If I want to make this bigger, I'll increase its height to zero point 0.2. If I want to make it bigger still, I can increase it further, and you can do that for all your dimensions. You can even change the text of your dimension. As we've discussed previously, if I wanted to display the units bright by each dimension, I can add that over here. I'll avoid doing that because that's redundant if all of your units are the same. Instead, what I'll do is that I'll add a note. Still within annotate, I'll add a note. I'll add a note over here saying all dimensions are in and you can use the same feature of adding notes to add additional details that you want. For example, when was this drawing created? Who was the designer over here? You mentioned your initials. In professional engineering drawings, you might have additional details as who reviewed the drawing and material specifications, your tolerance specifications. There are specialized functions for that in Creo as well. Feel free to explore those, but at the very least, the note tool is a simple tool that you can use flexibly. I'll move this slightly to the left so that it's above this. This is an acceptable engineering drawing, not very detailed, but it satisfies the minimum requirements of an engineering drawing. If you want to add more details, let me introduce you to a few more features. You can add what are known as detailed views within your engineering drawing. Let's say that I want to convey the details of these teeth to the viewer, but I don't want to zoom things up unnecessarily, and all the teeth are the same, so I don't need to zoom this entire view just to highlight the details of these teeth. So what I can do is that I can add a detailed view. Select detailed view from here within the layout tab. And what I'll do now is identify the region which I want to be zoomed in. The first thing that you do is generally, broadly, define the center of that region that you want to be zoomed in, and then, okay, we have to select a part on a feature. This is the center, roughly speaking, of the part of your drawing that you want to be zoomed in, and then draw a region around it using splines. Press the center mouse button when you're done, and select a point on your engineering drawing where you want a detailed drawing, a zoomed in version of this tooth to show. I want that to appear over here. You can always move that around, and the annotation tells the details of what this is. So it tells you over here that this circular region is shown in greater detail in view A. So detail A is this view. So you're directed over here, and the scale of this view is 4:1. So this has been zoomed in by a factor of 2. You can change the scale further if you want. And if you wanted to if you wanted to illustrate this dimension, you can now do that on the detailed view. Okay, let me see why that's not happening. Okay, so you can add this dimension over here, and for smaller dimensions using detailed views is is useful. Um, those are the basics of engineering drawing. Let's look at one more thing, how we can add section views. And this is something that we haven't talked about previously. If we go to our 3D model, let me get out of annotation over here, and then we can work on our 3D model. We can generate section views. Section views are views which cut through our 3D models, and they're very useful at displaying the insides of solid entities to convey details about the interior structure of our design. So if we want someone to see the there is isn't really any region over here, but let's say that there was some keyhole over here and we wanted to convey the details of that keyhole. What we can do is to remove everything to the right of this plane. So what I did over here was select a plane that I want to use as a cutting surface, and then select selection, which creates a section view. Everything to the right of that has been chopped off. If you want things to be chopped off on the other side, you could use this button. And if you don't want things to be cut exactly at the plane, but you want it to be cut at an offset, you can adjust the offset value either using this arrow or just give it an offset value over here. So let's actually go with this view. So once I click OK, a new section view would be created. Let's change the name of the section view. I'll change its name to A. Now we have a section view named A created, and you can work on your 3D design as normal within the section view. If you want to work on don't want the section view to be activated, you can deactivate it using this activation and deactivation button. Now in engineering drawing, let's add a new view. What I'll do is that I'll move this detailed view somewhere over here. Just trying to make some space. And what I'll do is that I'll actually create another projection view. You can do this with the general view as well. So I'll create another projection view to the right of this view, which should be the same view as this one. So it's the right view. And if I go to the settings in here, I can add section views. I want to add a 2D cross section. Select 2D, add a new cross section, and select from the cross sections that you've created, or you can create a new one as well. I've created a cross section that I've named A, so I'll select that. I want the entire cross section. And then to convey to the viewer where you want to convey to the viewer how are you cutting your design, you use these specialized indicator arrows telling the viewer which side are you viewing the part from and which side of the part of the design has been chopped off. You add these arrows, and we need to specify on which view we want to add these arrows to. So I'll add these arrows to this view. I'll select that, and now when I click apply, our section view is displayed. I'll talk about the details of that now. You click OK. So let's see what we have over here. So let me actually get rid of this detailed view node. What we have over here are these arrows, which are standard arrows for identifying section views. And what they are telling us is that we are looking at the part from this side, from the left, and everything to the right of this vertical dashed line is chopped off. So when we're looking at our design from this side, what we will see on the inside would be this uh, portion of the hole with, within the gear. That's what you see over here. This solid region, sometimes it's solid, sometimes it's hatched. Hatched are parallel lines at an angle. They illustrate that this is the inside of the part. So this solid region tells us that we are looking at the inside, and then there are certain portions of the outside of the gear which are displayed as well over here. So these arrows, they have the name of the section view, A, that's what we called it, and the standard way of denoting a section view is writing the name of the section twice with a hyphen in between, because the section is cut between those 2 points. So this is section AA. If you change the name of the section, this would be updated accordingly. So this is how you can add section views as well. If I don't want this view to be this big, I can modify the settings over here and reduce its scale. I think because it's a projection view, it has to follow the same scale as the original projection. Had this been a general view, I could have modified the scale. So let me just quickly repeat that. So I'll actually, what I'll do is that I'll work with this view. I know this is a general view, and if I go to scale, I can modify its scale independently. So I can make this bigger, and a general view has nothing to do with whether it's 2D representation or a pictorial view. A general view just means that it's not the parent of projection views that are generated from it. These are so this is a general view. I can change the scale over. I should be able to change the scale over here as well. If I change the scale over here to 1.5, the scale of not only this view is changed, but of the projections which are children of this view is changed as well. I'll revert this back to 2. I can create 3-dimensional section views as well. If I go over here, section, I am not sure why I'm not getting this option over here. Here, let me generate a new view. I'm trying to change the orientation, so I want it to be oriented in this way, and then I can add a 2D cross section. I'll use A. I'll add arrows to this view, and in this way I can create a 3-dimensional section view as well. If I want to look at the other side, I can go into the section view option, flip the cutting side, and then I can see uh, the other region as well. In this particular case, I don't really need to have this line telling me that it's section AA twice, because it's already displayed over here. So I can get rid of that from here. I got rid of the wrong thing. And get rid of that from here, and you can have a 3-dimensional section view. This is more crowded than a typical engineering drawing would be, but after you've added the principal multi-views and preferably one pictorial view, feel free to add section views and detail views as long as they're adding value. If they're not, don't overcrowd your drawing. In a similar way, you can make engineering drawings for assemblies as well. It's exactly the same. One thing that is different is that you can add exploded views as well. So let me quickly show that. But before I do that, I'll show you how you can save things as a PDF. The, no rocket science. Just save this as a PDF. I'll go with the default settings, and Creo should be able to generate relatively high quality PDFs which are displayed. Uh, so this is being pixelated in my case for some reason because I did have shading with edges on. My Creo has been acting up, but normally this should not be happening. So in this way, you can make three-dimensional. You can make two-dimensional engineering drawings that you can print out and use those for conveying your design. I'll close this over here, and I'll close this as well, and I'll open an assembly. This is an assembly that we've worked on previously, and I'll make an engineering drawing of it. I'll start a new drawing project. I won't use a default template. I'll use an A4 size landscape canvas again, and I'll add a general view over here. I want the orientation to be this orientation which I've created in the past. Actually, I'll go with the default orientation, not very illustrative, but it's good enough for the purposes I'm using it for. I'll increase the scale, and I'll create a copy of this over here. So I'll add a new general view. This I'll place over here. And for this view, what I want is for it to be an exploded view. Shading with edges, apply, and then in view states, you can enable different exploded views. I will use the default exploded view that is there for this assembly. You can create your own exploded views as we've discussed previously, and those should pop up over here as well. And when I click apply, this view, which in this case is a 3D pictorial view, but it could have been a 2D projection view as well, is exploded as per the specifications of my exploded view. So many times it's useful to show your assembly with everything assembled the way it should, and then have a second picture. It can be drawn to a smaller scale, which shows what are the individual components that make up your assembly. And then if you want to, this would not be an engineering drawing in the traditional sense. You can just have a big exploded view drawing and use annotations to label the different components, and that could help convey the design of your assembly. And if you're wanting to convey convey assembly instructions as well, those would be conveyed as well. So over here, if I reduce the scale for this exploded view, what I can have could be something like this, where I have the main pictorial view over here. I can have the multi-views top, front, and right over here, and I'll have a small exploded view over here, or you could do it vice versa as you wish. So this was an overview of generating two-dimensional drawings, engineering drawings in Creo from 3D models that you've made. Hopefully things made sense. Good luck exploring these features in Creo, and thank you for watching the video.